Okay, so good day class. So today our lesson is about quality control in concrete construction. So in this topic we will be talking about concrete. Okay, this is from in the standpoint of DPWH 2015 standards. Okay, so without further ado, okay, simulan na natin. So we talk about concrete. So when we say quality, so it is a degree of excellence, no? Pag sinabi natin quality, in Tagalog pa kalidad. Okay? Pag sinabi natin excellence, then siya, okay? Maganda yung kalidad niya o kaya mataas yung standard, no, hindi siya substandard. Okay, so when we say quality control, okay, it is the checking for conformance to requirements. So it is instituted during the course of construction as a preventive tool, not as a corrective measure. So pag sinabi natin quality control, hindi yung reactive ka lang, yung kumbaga pag may nakita kang mali saka ka magre-react, na sabihin natin yung concrete mo is under strength pala o kulang pala ng semento, for example. Masyadong maraming graba. Kaya hindi pasok sa standards. Okay? So isa lang 'yon. So hindi preventive tool siya. Ibig sabihin kinokontrol natin yung kalidad ng isang materyales. In this case, concrete. Okay? It is preventive tool. Ibig sabihin, gagawin natin sa simula. Hindi yung gagawin natin na huli na. Okay? So, this is the quality control formula. Okay? See, it is HQ. Okay? Close and open parenthesis times M plus W is equal to, okay, close and open parenthesis HQ plus E multiplied by S. So here HQ is high quality, then M is materials, W is workmanship, E is economical, S is structure. Okay, so dito na tayo. Okay, so what is concrete? Okay, ito yung main topic natin in these slides. So when we say concrete, it is derived from Latin word concretus, which means growing together. Okay, and this concrete is a mixture of cement, aggregates, and water. Okay, and specifically cemento, aggregates. Okay, pag sinabi nating aggregates, meron tayong coarse and fine aggregates. So yung coarse aggregates, yun yung graba. Okay, coarse aggregates, yun yung malaki. More than 2 inches ang laki ng bato, natatawag natin yang, depende. Pag sinabi nating graba, mga bato, okay, may standards na nagsasabi 2 inch, may nagsasabi rin na if more than 3/4 or 3/8, graba yon. Anyway, pag nakarating na kayo sa geotechnical engineering, madediscuss yun. Anong mga standards dun, meron niyang USCS and then Massachusetts MIT. Okay, so it is a mixture of cement, aggregates, and water. Okay, semento, graba, at anong buhangin, at saka water. Okay, yun. Aggregates is graba at buhangin, or coarse aggregates and fine aggregates. So when mixed in specific proportions, it hardens to strong stony consistency over varying lengths of time. Okay? So, kapag sinasabi natin concrete, itong tatlong to, itong cement, itong aggregates at saka water, depende sa design mo, meron siyang iba't ibang proportion, okay? So nagdedepende yan sa kung anong strength ang gusto mo or anong consistency yung gusto mo, okay? So, yan. So nagiging parang bato siya. Actually class, pag sinabi nating concrete, okay? Nami-measure siya in 28 days yung FC niya, okay? Pag later we will understand ano ba yung okay, kapag nagtrabaho na kayo sa construction especially, malalaman nyo na yung strength, ang strength sinusukat, ang strength ng concrete is sinusukat after 28 days, okay? It is assumed na doon niya almost 100% na-achieve ang strength niya. But of course, hindi theoretically, almost nandun na siya, almost 95 to 98% na yung strength niya, pero as time pass by, lumalakas yung concrete, okay? Not just 28 days. Anyway, medyo advanced na tayo. Advanced na yung pagkasabi ko. Anyway, let's proceed to the next slide. So, in concrete construction, good concrete will be produced where effective quality control is exercised. On the other hand, defective concrete will certainly result where there is little or no quality control. Okay? So, nagdedep sa pag-produce ng concrete, yung good concrete mapuproduce daw kapag merong epektibong quality control. Kapag wala naman, malaki ang posibilidad na magre-result sa depektibong concrete. Okay? So, let's proceed. Okay? So, as usual, ito yung composition ng concrete. So, major composition niya is yung paste. And then, this paste is composed of cement and water. And then, mineral aggregates. Ito na yung sinabi ko, coarse and fine. Pag sinabi natin coarse aggregates, yun yung graba. At yung fine aggregates, yun naman yung buhangin. Okay? So, the volume of paste, including air voids, is about 30%. And the volume of aggregates is about 70% of the volume of concrete mix. Okay? So, yung paste, 30%, itong cement and water, at saka yung aggregates is approximately 70% ng volume ng concrete mix. Okay? So, ito yung requirements ng concrete. So, first, it should be uniform. Okay? Sinabi nating uniform, homogeneous. Ibig sabihin, hindi, thoroughly yung mixture niya. Hindi yung iba, pag hindi mo kasi na ihalo ng mabuti, yung concrete, minsan, yung mga bato is nakakonsentrate lang dun sa kabilang panig. Okay? Kaya nagkukos ng honeycombs or yung ampaw. Okay? Then watertight. Then resistant to wear, weather, and other destructive agencies. So ito yung maganda dito. Okay? Ang dapat sa concrete. Meron siyang, in other words nito is, meron siyang strength. Okay? Ibig sabihin, hindi siya basta-basta nagwi-wear. Pag sinabi nating wear, yun yung parang nagpupunit-punit. At yung nagwi-weather, okay? Itong wear, yung para bang nagbabalat. Yung weather is parang kumbaga is parang napupulbos, okay? Hindi yun pwede. And then yung destructive agents. Maraming destructive agents, no? Okay, for example is pag yung concrete is nasa tubig alat, posibleng detriment yun sa quality ng concrete mo, or exposed siya sa lupa may mga chemicals, okay? May mga chemicals na destructive. So, yun yung iniiwasan natin. Okay? And then, it should not shrink excessively on cooling or drying, nor expand excessively on wetting. So, hindi dapat siya nagsishrink. Pag sinabi natin nagsishrink is parang lumiliit yung volume niya kapag nagko-cool or nag-dry. Or expand, pag sinabi natin expand, ito yung kabaliktaran ng shrink, yung para bang lumalapad siya. Okay? Due to wetting. Kasi dalawa yan eh. Kapag nagko-cool, nagko-compress yung concrete. Kaya posibleng mag-crack. And then, kapag nag-dry na siya, okay, posible ding mag-crack kasi nag-e-expand dahil mainit, okay? And then, it should have high resistance to fire, chemicals, or abrasion, okay? Dapat din hindi siya resistant siya sa fire o hindi siya naapektuhan ng apoy, okay? At ng mga chemicals at ng abrasion, okay? Yung abrasion is parang okay? Parang nababasag, okay? Yun yung abrasion, nababasag or nagbabalat, okay? And then it should, most of all, it should have a required strength. Ibig sabihin, dapat kung ano yung minimum strength requirements niya, dapat abot niya, okay? Speaking of strength, okay? Merong minimum strength required sa concrete, okay? To tell you, according to the National Structural Code of the Philippines, okay, it should be 17 megapascals, yung pinakamaliit na strength ng concrete mo, 17 megapascal. Samantalang sa DPWH standards mo, sa item 404, which is structural concrete, 16.5 or 2,500 PSI, okay? So, these are the factors that affect strength characteristics of concrete, okay? The principal factors that affect the strength of concrete are quality of aggregate and cement, quality of mixing water and cement, curing conditions, time mixing, and age, okay? So, naintindihan naman natin, no? Kalidad ng graba at mga graba at yung buhangin at saka semento, yung mixing water mo and cement, okay? Pag sinabing mixing water is meron kasing mga types ng water, okay? We will learn later kung ano yung mga types ng water na pwedeng gamitin sa pagmix ng concrete, okay? Actually, hindi pwede yung tubig alat kasi meron yung chemical na pag nilagay mo dun sa concrete is madali, hindi siya nagre-react siya dun sa semento, so ibig sabihin hindi siya masyadong nagmi-mix. O di kaya kung na-mix naman, hindi rin nagtatagal, nagka-crack na siya, okay? And then curing conditions, okay? Pag sinabi natin curing is para bang okay, malalaman natin to in the next slides. Ano ba tong curing, okay? Para hindi masyadong mahaba yung discussion natin. Then, time of mixing, paano pagka-mix, at yung age, o kung ilang araw na siyang, naka-install pagkatapos ng buhos, then saka siya ginamit, okay? Kasi hindi pwedeng na kakabuhos mo lang ng semento, gagamitin mo na agad, okay? So, these are the factors affecting strength and characteristics of concrete, okay? So, if concrete is well cured at any particular age, the most important single factor affecting the strength is water to cement ratio, okay? Water to cement ratio, ibig sabihin kung it's either by weight or by volume, okay? So, ano yung ratio ng water at saka ng amount ng cement mo, okay? Nang sa ganun is malaman mo na baka sobra o kulang yung tubig mo. The lower the cement ratio, the greater its strength, okay? To some extent, class, kapag hindi masyadong basa yung concrete mo, mas malaki yung posibilidad na mataas yung strength niya o kaya maabot niya yung standard niya, kasi kapag mataas yung tubig mo kumpara sa semento mo, magiging lasaw siya, or yung kumbaga parang yung ang tawag doon, yung parang basa yung concrete mo. Pag basa yung concrete mo, more likely hindi niya maabot yung standards, okay? Lalong-lalo na, okay? So maybe we will understand it better as we go on, okay? So eto, okay? So ito yung relationship ni strength at water to cement ratio. So nakikita natin dito sa graph na to, kapag habang tumataas si water cement ratio, okay, bumababa yung 28-day compressive strength. And speaking of 28-day compressive strength, class, ito, okay, ito, yung 28-day, ito yung strength. Kung ito yung day, pagkatapos ng 28 days kasi, yun yung sinusukat, okay? Whether you are using ASTM standards or as American Society on Testing Materials, or AASH2, or American Association of State Highways and Transportation Officials, and then adopted by the Department of Public Works and Highways in the Philippines, na yung 28 days, yun yung indication ng strength ng concrete mo. Kasi by theory, yun yung panahon kung saan na-achieve ng concrete mo ang almost yung strength niya, around 95 to 98% ng strength niya. So it's almost 100% of the strength. After 28 days, lalakas pa yung concrete mo pero hindi na siya significant, okay? So this is the result of research studies conducted by Duff Abrams, indicating the 28-day compressive strength and water cement ratio relationship for given materials, okay? And standard conditioning of making, curing, and testing can be represented fairly by smooth curve, okay? Ito yung study ni Duff Abrams, okay? So let's proceed, okay? So ito yung relationship ni water cement ratio mo at yung durability water tightness, okay? So paano ba natin i-interpret tong nasa graph? Okay. Meron kasing ideal niyan. Pag sinabi natin, hinahanap natin tong point na to, okay? This is water tightness and this is durability. Itong curve na to. Itong curve na to is, ito yung durability. Saka itong curve na naman to is for water tightness. Okay? So, kailangan nating itimbangin yung water tightness at saka yung durability. So, ito yung ideal. Ito yung intersection niya, yung ideal. Okay? So ibig sabihin, yung water cement ratio mo is dapat hindi masyadong mababa para maabot niya yung durability niya. Okay? Ideal durability niya. Nang sa ganun, is hindi rin na kukompromiso yung water tightness. Okay? So, this is the relationship of water cement ratio. So, the significance of water cement ratio is underscored by the fact that it affects not only compressive strength but also flexural strength, bond strength, durability, water tightness, and others. So, marami kang ibabalance out na properties ni concrete. Okay? So, let's proceed. So, the hardening process. Okay? Yung panahon na titigas na yung concrete mo. Okay? Siyempre, nagsisimula tayo sa buhos basa pa yung concrete. So habang tumatagal is naku-cure siya at tumitigas at hindi na siya nagiging basa. So ito yung hardening process. So this process is a long way, okay? So when Portland cement is mixed with water to form a paste, the compounds of cement react with water to form cementitious products which adhere to each other and to intermix fine and coarse aggregates and became very hard. As long as moisture is present, the reaction called hydration may continue for years. Okay, ito. So, sinabi ko na, yung concrete mo is continuously nag-i-improve for years. Pero but somehow at 28 days, almost achieve na yung full strength niya. Okay, kaya doon tayo nagko-concentrate. So if the paste is not kept wet, any hydration of cement cases when the evaporable water escapes from the paste. Okay? So these are the quality control measures ng concrete. So the quality control measures in concrete construction that are necessary for the production of concrete that will satisfy service requirements are, okay, selection of materials, design of concrete mixture, okay. Dito papasok yung, okay, ano bang klaseng mixture ng materials mo, okay? Class A ba? Class B? Class C? Class P? Or Class AA, okay? Then, sampling of concrete. So, ito yung ginagawa natin. Kailangan kumuha tayo ng sample as a representative ng concrete na binuhos natin sa site. Saka, yun yung iti-test natin, okay? Testing of concrete, yun yung iti-test natin kung papasa ba siya sa minimum requirements. And then, control in placing concrete, okay? Paano i-control yung placing ng concrete? Then, curing of concrete samples, okay? As we go on, ma-understand din natin ano itong curing at ano itong ibang bagay na nandito, okay? And then, protection of concrete, okay? Hindi lang yung concrete na nagtatapos lang pagkatapos mong ibuhos. Kailangan mo rin siyang, okay, tabunan. For example, baka kung nagbuhos tayo sa daan, baka may dumaang aso o baka may, pag hindi natin kinunong, baka may dumaang motorista, malambot pa yung concrete kaya magkakaroon ng irreversible damage, okay? Mahirap okay. Ito, start tayo sa selection of materials, okay? So, ito yung mga ingredients ng concrete. Hindi ko na basahin. Cement, coarse aggregates, fine aggregates, water, and mixture. So, importante daw na ang materials natin is mapili at ma-inspect ng mabuti. Okay? To satisfy the quality used. Okay? The quality of concrete is greatly dependent on the quality of individual ingredients. So, it is also important that materials are properly stored, handled, and used in work. Okay. So, aggregates. Pag sinabi nating aggregates, sinabi ko na dalawa yan. Coarse aggregates, yung graba or sa Bisaya pa grabas. Then fine aggregates, yung buhangin or yung yun sa Bisaya yung buhangin? Balas. Okay? So, coarse aggregates, grabas. And then, fine aggregates, balas. Okay? Although the fine and coarse aggregates represent the major volume of concrete, 70%, the important role they serve as the principal ingredient is often overlooked because, okay, their cost is much less than of cement. Okay? Pasensya na, medyo alas 10 na pala habang nagre-record ako nito. Okay? Curfew. So, ito. Okay? Pag sinabi natin coarse aggregates, it is consist of crushed stone, gravel, or blast furnace slag, okay? Or other approved inert material. So, hindi lang yan actually class gravel. Okay, pag sinabi natin gravel is yung bato ba na meron pang kasamang graba na maliit, at saka yung crush stone. Okay, pag sinabi natin crush stone, yun yung bato na malaki na kung sinadya nating pasabugin. Okay, and then ito yung blast furnace slag. Okay, parang resulta to ng blasting, yung blast furnace slag. Okay, so merong materials na tinatawag na slag. So pwede rin yung gamiting coarse aggregates. Usually yung coarse aggregates class is yun yung bato na malalaki, usually 3/4. Okay, mayroon nagsabi na kapag more than 19 mm, okay, or 3/4, yun na yung graba or coarse aggregates. Kapag mas mababa sa 3/4, yun na yung fine aggregates. Okay, so eto na naman. Okay, so in selecting an aggregate, the following criteria should be considered. Okay, grading. Okay, grading should be uniform. Okay, an aggregate with unfavorable shape particle should not necessarily be rejected. Okay, if other alternatives are very costly. And then an aggregate that will not produce concrete of the required strength should not be used. Okay, so yung mga aggregates na hindi maganda yung quality, no, na posible maraming halong ibang materials like lupa. Okay, pag hindi kasi maganda yun sa aggregates na marami siyang lupa o marami siyang putik, kasi nakakaapekto yun sa strength ng concrete mo. Okay, the aggregate should exposed to severe weathering should not be used. Okay, and then aggregates containing substance that react with alkalis. Pag sinabi nating alkalis, yun yung mga types ng compounds or chemical compounds na na tulad ng sodium sulfate, calcium sulfate. Okay, yun, if na-review nyo yung alkali at alkaline earth metals nyo, okay, yung nasa periodic table, yung sodium, calcium, okay, yung potassium, and then there's sulfates and nitrates. So yun yung alkalis. Okay, so in general, it is required that the aggregate shall be clean, hard, durable, and sizes should be within specifications. Okay, so ibig sabihin dapat clean siya, ibig sabihin dapat pure siya na gravel, hindi wala siyang halong putik, wala siyang halong lupa. Okay, hard, sound, hindi yung sound na tulad nung narinig natin kanina, yung sa curfew. So hindi yon yung sound. And then yun yung ibig sabihin ng sound is magandang tingnan. Okay, parang maganda yung quality sa paningin. And then durable. Okay, then sizes would be in specification. So ibig sabihin hindi siya dapat oversized yung coarse aggregates mo. Hindi na wala na yung mga bato na mas nalalagpas pa siguro ng na parang kamao na kalaki. Hindi yun pwede. Dapat usually mas maganda if yung pinakamalaking bato mo is 2 inches lang. Kapag lumagpas ka na sa 2 inches, okay, so between 3/4 inch to 2 inch lang. Pag lumagpas ka na marami ng significant na yung lumagpas sa 2 inch, hindi na maganda sa concrete yun. Okay, so then again, ito yung grading requirements natin. Okay, so ito yung so tingnan nyo na lang, class. So hindi ko muna siguro to discuss ng mabuti. Okay, grading A, grading B, grading C. Ito yung iba't ibang grading. So meron kang standard size na sieve, parang salaan ba, 75 mm, ibig sabihin 3 inch yung laki ng sieve. Okay, so proceed muna tayo sa next slides para maintindihan natin yung ibig sabihin ng grading. Okay, 3 inch, 2.5 inch, 1/4 inch. Okay, so dapat halos wala nang natitira dito sa 1/2 inch mo, kasi na yan. Pag sinabi natin coarse aggregates, majority niyan is above 19. mm. Okay? And then, mas ideal if dito pa lang, sa 50 mm or 2 inch, ang pinakamalaki. At yung nasa itaas naman, more likely, dapat less than 10% na lang yung umaabot ng in between 2 to 3 inches. Okay? So, let's proceed. Okay, ito na naman. Dito na tayo sa fine aggregates. Pag sinabi nating fine aggregates, it's natural sand, some screening, or other inert material. So, material passing 0.075. Okay? Okay? Pag sinabi nating fine aggregates, hindi man nakalagay dito, ito yung less than 3/4 or less than 19 mm. And then, meron siyang mga, okay, according to DPWH standards, dapat yung material passing niya sa number 200 na sieve shall not contain more than 3 more than 3% mass percent by washing or 1 mass percent of clay lumps or shale. So ito na yung sinabi ko. Pag sinabing clay lumps or shale, yun na yung mga kumbaga sa Bisaya pa is lapok or mga putik. Hindi yun pwede. Pag umabot na ng lagpas 1%, masama na yun. Then, okay, okay, so ganon. Then, when subjected to 5 cycles of sodium sulfate soundness test, isa itong uri ng soundness test, okay? So, isa itong uri ng test para sa fine aggregate. So, when weighted, low shall not be exceed 10 mass percent. So, next time, okay? So, we should proceed para mas maintindihan natin ano ba itong ibig sabihin nito, okay? So, this is the grading requirements ni aggregates, okay? So, dapat, kay 9.5 mm, majority is pumasa. Ibig sabihin, at 9.5 mm or 3/8, dapat pumasa 100%, okay? Actually, pag sinabi nating meron kasi niyan dalawang standards, meron yang USCS at yun yang meron din yang from Massachusetts Institute of Technology. So you will matututunan nyo din yan sa sa geotechnical engineering nyo, okay? So 9.538, okay, dapat po pasa siya lahat. And then hanggang sa yung masyadong maliit is konti lang, yung para bang sobrang pino na. So hindi rin pwede na masyado siyang pino. Marami siyang masyadong pinong bahagi. Okay? Okay. So punta naman tayo sa cement. Okay? Ano ba tong cement? So cement is a byproduct of lime, silica, alumina, and iron. Okay? The main component is lime, which is around 60 to 65%. Okay? Maybe if you will consider, maraming pag ni-research nyo, matatandaan, makikita nyo ano ba tong lime. Anyway, makikita natin sa mga susunod na slides. So, there are different types of for cement usage. Okay. Anyway, maybe mag-open tayo ng another. Okay? So mag-open tayo ng another about cement, okay? So ito 'yun. Pag sinabi nating concrete, ganito yung niya, okay? So meron kang, okay, zoom natin. Yan. Cement, water, sand, gravel. Okay? Ito yung ibig kong sabihin. Yung sand, okay, yung sand yun yung fine aggregates at yung gravel naman yun yung coarse aggregates. At minsan meron siyang admixtures. Yung admixtures naman is i-discuss natin, merong admixture na nag-a-add ng strength sa concrete. Meron ding nagpapalapot ng concrete para madaling i-mix. Okay? Depende yun. So we will discuss it later. Okay? Para meron tayong yan. Okay? So, yan yung concrete. Okay? So dito, according to this, concrete is composite material that consists essentially of binding medium. So mixture of cement and water. Okay? Ang binder na, so meron kang aggregates at meron kang binder or cement paste. Mixture of cement and water, dun sa kabila is sinabi dun is cement paste. Pwede ring binder yung tawag. And then binabind niya together yung aggregates para parang maging bato. Okay, balik tayo dun. So, ito yung cement. So, merong different types of cement. Depende. Okay, depende kung ano yung kailangan mo. Depende sa lugar mo. Okay, whether posible nasa Middle East ka. So, kailangan ng, kasi mainit doon. So, kailangan na slow yung concrete mo na tumigas. So, kailangan mo mag-specify ng type ng cement na pwede sa kalagayan ng weather mo or kalagayan ng kung mainit ba o masyadong malamig, depende. Okay? So, yung pinaka-common type is type 1. Okay? Dito sa kabila siguro hanapin natin sa yung type 1. Okay? So, by the way, ito yung composition ng concrete. Okay? May air, may Portland cement. Okay? Almost 70% nga yung coarse and fine yung aggregates mo which is 41% is gravel and 26% sand. Actually, approximate lang to siya, class. Hindi sa lahat ng panahon ganito talaga. So, this is an approximate distribution ng concrete composition. Yan. So, proceed muna tayo dun sa kabila. Merong type 1. Ito yung most often. Okay? Merong types ng cement. Meron yung Portland cement. Okay? So, it's produced by pulverizing cement and clinker gypsum. Meron din tayong, okay, ito yung Portland cement. Okay? Clinker, yan okay? Plus gypsum, okay? Is equal to Portland cement. Type 1. Okay? Okay. Portland cement na meron kasi yan. May Portland. Maliban sa Portland cement, meron din yang blended cement. Okay? So, itong blended cement is consisting of 2 or more inorganic constituent separately or in combination, which contribute to the strength gaining properties of the cement. Okay, ito yung blended cement. So, meron na tayong dalawang types ng cement. Yung Portland cement at saka yung blended cement. Pareho silang hydraulic cement. Okay? And then, Portland pozzolan. Okay? So, blended hydraulic cement consists of intimate and uniform blend of Portland cement or Portland blast furnace slag cement and fine pozzolan blended within specific limits. Pag sinabi nating pozzolan, class, is, okay, pwede nyong i-research yan sa internet, pero kung nakita nyo yung yun yung, kung nakita nyo yung movie na Pompeii, okay, yun yung nilalabas ng bulkan, okay, yun ang tawag doon sa na yun, yung materialis na binubuka ng bulkan na parang pulbos, na later is na-discover ng Roman scientist o ng Roman Empire na pwede siyang ihalo sa tubig at saka sa aggregates para maging semento. Yun yung pozzolan. Okay? Yun yung pozzolan. Para siyang para siyang semento ng Roman concrete. Okay? So, you can research para internet, you can search sa internet para mas maintindihan. Okay? So, let's proceed. So, ito yung pozzolan. Okay? Welded tough and pwede itong welded tough, pwede itong fly ash. Okay? So, ito yung natural pozzolan. At ito naman yung artificial pozzolan. Merong dalawa niyan. Okay? So, ito. Ito yung Portland pozzolan. So, basically, meron kang clinker, gypsum, nagiging Portland cement, yung ordinary Portland cement. Pero pag sinaluan mo ng natural pozzolan, for example is ano yun? Welded tuff or fly ash, nagiging Portland pozzolan siya. Pag nilagyan mo naman ng blast furnace slag, nagiging Portland blast furnace slag cement siya. Okay? So tatlo, may Portland cement, may Portland pozzolan cement, may Portland blast furnace slag cement. At meron din yung na-mention na yung una, yung blended cement. Okay, actually itong Portland blast furnace slag and Portland pozzolan cement, blended to sila pareho. Okay. So pag sinabing Portland blast furnace slag, okay? So it is blended hydraulic cement containing of interground mixture of Portland cement concrete and granulated blast furnace slag blended within specific limits. Okay, tingnan natin dito, baka meron. Okay. Meron yata dito. Dito sa kabila. Okay. Yan yung coarse aggregates. Okay. May malaki, may maliliit. Wala. So, susunod na lang. Okay. Yan. May clinker, may gypsum ka na, at may ito yung blast furnace slag. Okay. So, nagiging ito yung semento. Okay. So, marami tayong uri ng So, kayo na lang magbasa niyan. So if we freeze ko ng ilang minuto, okay? So, maybe dito muna tayo mag-pause. Dito muna tayo tumigil sa video na to. At patuloy tayo sa part 2 para hindi masyadong mabigat i-upload. Okay? So, ayan. Merong T1, T2, T3, T4, T5, T1. Okay? Depende sa intended use or application. So, okay. So kita tayo dun sa second video.